you sick?
Yep.
Or were you sick?
Sick?
Were you like that?
Yeah, no, I was like, oh my god.
Oh. Hey, first, let me pass back.
What was we missed like 3 days?
Yep.
Yeah, I forgot to. I forgot to switch it.
Yeah, sure.
It's supposed to be.
The length of the rectangle is top minus bottom.
Oh, yeah.
Oh, no, no. Yeah, but it is nice.
Semicircle is 1/2 pi r squared.
Troops are already cooking up.
Oh, that thing goes over the whole thing.
How does Teruya keep beating me?
Yes.
How? My life is over.
Algebra mistake, and I don't know how you add those up against the
Again?
1/2 pi r squared. Semicircles.
This is supposed to be 8 thirds. You know how that's supposed to be? Actually, take the square off, and it's just 2 minus x dx. Therefore, it's still kind of weird. Like, why do they so
The length of the rectangle is top minus bottom. And then, since you're doing the integral in terms of x, it's going to go from 0 to 4.
Yeah, you beat you.
That point is 4 comma 5.
It's if Teruya beats me. We have our optics test.
You got the wrong boundaries on
Oh.
it.
I haven't got over it.
So top minus bottom.
I read the book today. No, I read the
Yeah,
book.
but then, if it's not right, how can you figure out those?
I figured out what a real image is, a virtual image. Figured out what positive and negative distance is. By reading the book.
Oh, yeah.
Magnification is HI over HO, or negative BI
Oh,
over
I'm down.
Semicircles.
and two-
Oh, 1/2 pi r squared. There should be a
Or
1/2.
the
Oh, okay.
internal reflection. Yes.
I know, I saw it. So 3 people absent? Oh, good thing we're videoing then, huh? Okay, today we gotta take care of all questions. Anyway, look at the calendar. You guys gotta be aware of what's happening. Tomorrow is the test. And then next week, Monday and Wednesday are reserved for math.
That's 2 minus.
So this is gonna be the test for you.
Oh.
So probably next week for AB, quiz, test.
What's the next test gonna be?
Is that the calculator?
Whatever we learn tomorrow.
Oh, yeah.
Wait, what?
No, we're gonna learn the
That's
That's how it's
the test.
Anyway, first order of business is tomorrow's test. Oh, no, wait a minute.
We should push it back.
No. So we're gonna learn something tomorrow, because remember I told you we're gonna have a test on solving computing areas and volumes using your graphing calculator, yeah? You're gonna get a worksheet on it. Anyway, that worksheet is on the website. I thought we might have that test over here, but it's not reserved for math, so we could have it there.
Yeah, that works.
But then I'm thinking we should have it here and then combine it with the other stuff we learned.
Okay.
I don't know, just worry about tomorrow's test first. Anyway, there is gonna be a test on using your graphing calculator.
He's gonna do it right, and I see him coming in as a 100.
It's been doing that lately. Anyway, did you guys watch the video
I watched
that I
it.
made? Didn't it say on the sign outside, watch the video?
And in the
And the email that I sent? Well, then you should. Okay, now, okay, let's go. Disc? We got a disc question? Oh my gosh, if we have a disc question, we're in grave trouble. Now, some of you, wait a minute, I did this on the board. I remember doing this on the board. Oh, I did it on the video, that's why.
Oh no, no, it's on a separate video then.
What do you mean? I remember doing this problem.
Now we did it.
Yeah, we did the problem. Who put 27 up? Wayne?
Suzuki.
That's not Suzuki's writing. Okay, washers. Anyway, we finished with this already, right? Washers, 31. What? Okay, here we go. The region. Now, tomorrow's test, I'm probably gonna give you most of the graphs, if not all of them. But you better understand what bounded means now. Bounded means enclosed by. So, because every year there's always 2 or 3 students that are picking the wrong region. Bounded means enclosed by. So, 1, 1, 2, 1, 1, 2. No, 1, 0. There, this is the region in question. Now we're going to revolve it about the y-axis and we're going to make washers. Okay, now, again, I'm going to repeat. What determines whether it's a disc, shell, or washer? The rectangle. Which way you draw the rectangle. Every year, students think, oh, if you revolve it about the x-axis, that's going to be a washer, but if you revolve it about the y-axis, it's going to be a shell. No. The rectangle tells you what it's going to be. So if you don't draw your rectangle in or the picture, then that's where you're going to be in trouble. Okay, so if I'm going to revolve it about the y-axis and I want to get a washer, which way do I draw the rectangle? Horizontally. This. I think I said it on every single video, right? The rectangle tells you what the shape is going to be, not what axis you revolve it around. It's the rectangle. So if you don't draw the rectangle in, you're going to be in for cruising for a bruising tomorrow. Okay, so, and remember, okay, if you make the rectangle horizontal, that means you got to solve for y, yeah? So this is easy. This is y equal, that's a horizontal line, people. Y equal, it's a horizontal line. Y equal 1. Now, what about the equation of this line? What's the slope of this line?
Isn't it x equal 1? That horizontal line?
Oh yeah, it's x equal 1.
Wait,
It's x equal 1. What am I talking about? Oh yeah, x equal 1. And then over here, what's the equation of this line?
x minus
Y equals, what's the slope? 1, but then the y-intercept will be negative 1. But then you have to solve for x, so x equals y plus 1. Okay, so here we go. Pi. Are you guys automatically doing this on your paper? Pi, big R squared minus little r squared for a washer. Okay, now the big radius goes from the center to the outer edge. How do I find this distance? Right minus left. Which one's on the right? Y plus 1. What's on the left? 0. So y plus 1 minus 0. The inner radius goes from the center to the inner edge right there. How do I find that distance? Right minus left. 1 minus 0. So that's 1. And then you add up all of these from, since you're doing it with respect to y, you go from the y coordinate down here to the y coordinate up there. 0 to 1. I'm not going to compute these for you. You guys, that's a polynomial, right? You guys can do that. 37C. Okay, so first you got to have the graph. If you don't have the graph, it's pretty much all over but the crying. And the line y equal 1. And then in part C, we're revolving it about the line y equal negative 1. So if I want to get a washer, which way do I draw the rectangle? Vertically, because it's got to be perpendicular to the axis of rotation. and then it's not touching, so it's gonna be a washer. Okay, so pi big R squared minus little r squared dx. How come dx? How come that one's dy but this one's dx? Because the rectangle is vertical. If the rectangle is horizontal, it's dy. If the rectangle is vertical, it's dx. It's very simple. The rectangle tells you everything, not the axis of rotation. Okay, so big R goes from the center to the outer edge. So how do I find this distance here? Top minus bottom. Okay, look, this is y equal 1. This is y equal x squared. So what's top minus bottom? What's 1 minus negative 1? 2. The small radius goes from the center to the inner edge right there. What's that distance? What's top minus bottom? X squared minus negative 1. So that's x squared plus 1. And then you add up all of these washers from negative 1 to 1, or you want to go 0 to 1 and times by 2? If I were you, I would go 0 to 1 and times it by 2, because you guys have problems plugging in negative numbers, yeah? See how easy this is? You just gotta practice a few times. So those of you who think you're just gonna get by, you're gonna have 2 tests on this now. Because if you don't set up the integral correctly, that's it, that's a fatal error. And same thing on the graphic calculator. You don't set up the integral correctly, it's a fatal error. You can't get any points, yeah.
How would you draw the washer if you revolve it around 1, or y equal 1?
Then that would be a disk.
Oh, it's just a disk.
Yeah, because it's touching, because if y equals 1 here, look, whenever you look at the rectangle, however you draw it, it touches the axis of rotation, so you're going to get a disk. Okay, and then shell. Shell is the hardest one of the 3. 41. But if you watch the video, anyway, we went over it, right? What am I doing? Just draw the darn picture. Y equal root x, y equals 0, x equals 4. So tomorrow I'm going to give you this picture, but you better know we're talking about this region right there, right? It's going to be bounded by it. Okay, now what are we doing? Revolve it about the y-axis using shells. So if I want to make a shell, what? Which way do I make the rectangle? Here's the y-axis. You got to make it vertical because the rectangle has to be parallel to the axis of rotation to get a shell. Now tomorrow's test, you're going to have to do it both ways, you know. I'm going to ask you to do it one way and the other way. So you can't just know one way, you got to know both. There's the shell and it has a thickness to it. Now remember, what did I tell you? Label this point X, Y. And the reason is because, look, if you label a point X, Y in the Cartesian plane, doesn't that mean this is X and that's Y? Okay, so for a shell, what's the formula? 2 pi radius height dx, since we drew the rectangle up and down. Okay, this is the radius right there. Look at the shell, that's the radius. What's that? That's x, right? Because look, you label the point x, y, the distance from the y-axis to the point is x. That's x. And the height of the shell is always going to be the length of the rectangle. For those of you who did the problems, yeah? The length of the rectangle is always going to be the height of the shell. So how do you find the length of the rectangle? Top minus bottom, just like we always do. How do you find that? So what was the equation on the top? Here, I'll write it for you. And this one was y equals 0. So what's top minus bottom? Root x minus 0, which is root x. Add up all from 0 to, what's this? What's the x coordinate here? 4. How do you know? Because it says x equals 4, right? Because if you get your wrong limits of all you got to do is look at the region. The region tells you what the limits of integration are going to be. If you do it in terms of x, you go from the x coordinate here to the x coordinate there. If you do it in terms of y, you go from the y coordinate here to the y coordinate there. The region tells you what your limits are going to be. Isn't this kind of easy? Okay, don't answer. 42. Where's 42? Okay, y y equal 2x minus 1, so it's going to look kind of like this. Y equal root x, okay, here's the point 1, 1, so and then x equals 0 is this, is the y-axis, so this is the region right there. Take that region and revolve it about the y-axis. So if I want to make a shell, what kind of rectangle do I need to make? Vertical.
Wait, isn't it x
I
equals
think
0?
we can make 135.
Well, what he told us yesterday was that he walks around at no.
No, on the Ustream thing, there's the, I don't know, they have this thing. I pause it, but the thing just keeps going every once in a while. Anyway, if I revolve it about the y-axis, you're going to get the shell right here. See, some of you guys not even drawing in the picture. That's why you guys have problems. Anyway, tomorrow, you get it wrong. If you don't have the picture, I can pick up triple.
Uh-oh.
Okay, so this is a shell. 2 pi radius height dx. dx because you drew it vertically. Okay, what's the radius of the shell right there? And see how I labeled that point xy? Anytime you do a shell, label that point xy. So what's the radius of the shell? X. Because x tells you how far you come out from the y-axis, right? And then again, the height of the shell is simply the length of the rectangle. Looking at you, Akiro, organizing your folder. Top minus bottom. Which one's on the top? Root x minus the bottom. Which one's on the bottom? 2x minus 1. And please distribute that minus sign. Add them up from 0 to, now what's the x coordinate over here? Well, I already told you that point's 1, 1. Now tomorrow I'm going to give you the graphs. I'm not going to give you the points of intersection. You better know that's 1. Anyway, you know I'm not going to make the x and the y coordinate come out the same because otherwise the people who don't know the difference will get it correct, right? You know what I'm talking about? It will be different, the x and y coordinate. So it's not going to be 1. Yeah.
Like that's always x, like, could we say that this is always x, y, right? When you draw the, like,
So what's the question?
would it always be x?
This.
Yeah.
If you draw a vertical rectangle and you're revolving it about the y-axis. So if you have a shell and you're revolving it about the y-axis, yeah, then the radius is always going to be x. But then, what if I ask you to revolve it about a different line? Then it's not going to be x, right? Yes, if it's about the y-axis, but like I said, it's not. Okay. What the heck is going on? What is BID? I see an I. 35. Oh, so it was you.
35.
So 35. Find the volume of the solid generated by revolving the region y equal root x. How many times this graph has come up? So here's the 1.11. The line y equal 2. Ooh. And x equals 0. So this is the region right here. So obviously this is the point 4 comma 2, right? Because the square root of 4 is 2. Now it says revolve it. Well, what number are we looking at? D, the y-axis. Come on, y-axis is easy. Okay, so you draw in the rectangle. Revolve it about the y-axis. You get a shell. Label that point xy. So what's the volume? What's the formula for a shell? 2 pi radius height dx, since the rectangle is vertical. What's the radius? X. And the height is simply the length of the rectangle, top minus bottom. 2 minus root x. See, that's like the quiz. Add them up from 0 to 4. The region is going to tell you your limits of integration. So you just look at the region. Okay, now 35, what are we doing? D. X equal 4. Should I even draw it in? No, let's just draw another picture. Okay, this is where some of you might have problems. Okay, so here's the region. Here's the point 4 comma 2. We're going to revolve it about this line now. rectangle, if this rectangle goes around the line, you're gonna get a shell. That's ugly. Oh god. So 2 pi, doesn't matter, 2 pi radius height dx. Okay, now, if you label this point xy, it doesn't matter if you label it here or there, it's the same distance. What's the radius? Okay, this is the radius of the shell right here, right? Well, we know that from here to here is x, right? From here to here is x. From here to here is 4. So what's the radius of the shell then? 4 minus x. Look, if from here to here is 4, if from there to there is x, then what's that? Wouldn't it be big minus small? 4 minus x? That's algebra 1, right? Okay, and then the height of the shell is always going to be the length of the rectangle, top minus bottom. Which one's on the top? Look at the equations over there. Top minus bottom. 2 minus root x. Add up all of these shells from 0 to 4. And now you just multiply out. So down to 35b, just multiply out, and then we each integrate term by term. Easy. We haven't even come across a u substitution or a trig one yet. So it looks like the problem is writing the integral, which of course is going to be a problem, because if you don't write the correct integral, then that's a fatal error. Okay, so we're done with the book homework. And like I told you on the video, number 52 is on the test. Plus you had another chance added on the practice worksheet, right? The one the bowl is filling up. That's the last problem on tomorrow's test. Anyway, I always check that one on the homework too. Usually in this chapter, I'll just give you a heads up. I usually check the even problems, but some of you are rolling the dice. Yeah. Okay, all we got to do is go over the review worksheet problems. Okay, first one, 2. Okay, somebody, I don't have it with me. What is it? Let me see. Okay. Just put it down. Y equal e to the negative x, x equals 0, x equal ln 2. So y equal e to the negative x looks like this, right? X equals 0 and x equal ln 2. So, there. We're going to do A and B. See, everybody can do number 1. See how I make you do it both? You're going to have to do it both ways. That's number 1 on tomorrow's test. In fact, the test looks just like this, for Pete's sake.
So we just have to do the
Okay, x-axis, then the y-axis. Okay, take this region, revolve it about the x-axis. So, now some problems you only can make one rectangle. How come I can't make horizontal rectangle here? Well, why would you want to, since the equation is y equal e to the negative x, right? But why would you not want to do horizontal rectangles? Because the right minus left changes. See, like over here, right minus left. But then once you hit this point here, then the right minus left the changes. So why do you want to make like separate integrals, right? So this one, you kind of forced to do it this way. If I revolve it about the x-axis, there's a disk. What's the formula for this? Pi times the radius squared dx. How do I find the radius? Well, that's just the length of the rectangle, which is top minus bottom, e to the negative x minus 0, add them up from 0 to ln 2. And then, of course, come on, that's on the list, right? E to the box. You want me to go one more step?
Yes.
Oh, God. Take out the pi, and then you multiply the exponents. So is the antiderivative of e to the negative 2x just simply e to the negative 2x? No, because I left the space. The derivative of the box is negative 2, so how do you adjust for it? You need a negative half in the front, and then from 0 to ln 2, and if I were me, I would factor out the constant. And then, can you guys plug in ln 2? Because some of us still have problems with that, yeah? If I plug in ln 2, let's just go one more step, because I don't want to see this tomorrow. I want to see something good. If I plug in ln 2, what is e to the negative 2 ln 2? What is e to the natural log banana? Banana. So what you gotta do is make it look like that. So when you have a logarithm, what can I do with this number in the front? Put it up as the power. So e to the natural log of 2 to the negative 2, which is simply 2 to the negative 2, which is 1/4. That comes up all the time on the AP exams. That's why I keep giving it to you guys over and over. You guys gotta handle that. And again, some of you think when you plug in 0, you get 0, no boom spread. If I plug in 0 there, e to the 0 is 1. And then can you go to one more step to simplify? No, wasn't too bad. Okay, B, now we're gonna revolve it about the y-axis. So it's the same region. Now tomorrow, I'm giving you the picture, so there's no excuse tomorrow. Now if I revolve this about the y-axis, you're gonna get a shell. Here's the point x, y. See how I do the same thing over and over? See, you guys don't do it. 2 pi radius height dx. Okay, what's the radius right there? X. You label a point xy, that's x, and this is y, right? But since we're doing it in terms of x, you want x's in here, right? How do I find the height of the shell? It's always going to be the length of the rectangle. Top minus bottom. What's the equation at the top? E to the negative x minus 0. And then you add them up from 0 to ln2. And then
You know, like
a
sweets or any type of drinks or anything like that?
yeah. How do I do this integral? See, you guys don't know basic integration techniques.
Tabular.
Tabular.
I know what's up. I did the homework.
I'm not going to congratulate you on something you're supposed to do. Tic-tac-toe. So you throw the 2 pi on the outside and you got negative x. You guys can copy down all you want. You guys got to do this on your own tomorrow. And then you guys know how to plug in ln2, right? E to the negative ln2.
1/2.
Put this up as the power. E to the natural log banana is simply banana, which is 1/2. 2 to the negative 1 is 1/2. Okay, let's just keep moving on. Number 3. That's pretty much the whole worksheet, people. We're going to run out of time.
Because you didn't put answers at the bottom.
I did. It's on the second page.
Oh,
Blank,
Yeah.
blank.
I never got it.
Number 3. Blank, blank, fill in blanks. Let your imaginations go off with you. Y? Mr. Park, I don't know what y equal 1 over root x squared plus 1 looks like. Well, neither do I. No, I do. But look, you don't need to, because it's bounded by x equals 0. Look, if you plug in 0, you get 1. If you plug in root 3, you get something smaller than 1. So it looks something like that. I taught you guys this shit. You plot the points at the endpoints, it's connected, man. Okay, part A, what are we doing? We're revolving it about the x and the y. Come on. Okay, if I revolve it about the x-axis, a shell. That's not a shell, that's a disk. Y times the radius squared dx. How do I figure out the radius?
Top minus
Top
bottom.
minus bottom, so it's that minus 0.
Oh, that comes up.
Add them up from 0 to root 3.
Oh, no, never mind.
And then when you square that, hey, that's on the list.
Tangent.
Tan inverse, not tangent.
I said inverse.
No, you didn't.
It's actually that.
Like, it's on the video. When you go listen to it.
Let's go listen to the video.
Okay, now part B, we're revolving it about the y-axis, right? So same graph. Ooh, that's ugly. So I do one like that. Now, if you revolve it about the y-axis, that's when you're gonna get the shell. So those of you guys not drawing the rectangle in. No wonder it's confusing. Because you're just trying to guess what it's going to be depending on what axis you're revolving it around. The rectangle tells you everything. It's the rectangle, the strip, like Jaime Escalante called it. 2 pi r h dx. What's the radius? What's the radius? S. When you label a point xy, it's there for a purpose because from there to there is x. And then the height, the length
Top
of the
minus
top
bottom.
minus bottom. So what is the top? 1 over root x squared plus 1 minus 0. Add them up from 0 to root 3. And what what technique do I use on this one?
Use substitution.
U substitution. I'm just gonna start you on it, and then you guys gonna have to take the baton and run. Anyway, you guys got. Come on, you know, spring break is coming up, and then, you know, after today, that's it. We're not learning anything more. You only got to know 2 techniques on the AP exam. It's either on the list or use substitution. Integration by parts is not on the AP exam. But some of us are still hazy on use substitution. Oh, very good. We did number 4. Okay, number 5. Y equal 1 over 1/√1 minus x. I don't know what that graph looks like. Neither do I. 0 to 1/2. So you don't know what the graph. Anyway, tomorrow I'm going to give you the picture, right? So come on. All you got to do, plug in 0, you get 1. Plug in 1/2, you get something smaller than 1. Or no, it's bigger than 1, so it goes up. Who cares if it goes up or down? You're going to get the same integral anyway, right? Okay, then we got to go find the area. Then you got to revolve it about the y-axis. Okay, how do you compute area? Come on. How do you compute area? You just add up all the rectangles. What's the length of the rectangle? What's the length of the rectangle? Top minus bottom. Multiply it by the width and just add it up from 0 to 1/2. That's it. That's how you find area, right? Okay, that's on the list. Sine inverse, right? Okay, part B, revolve it about the y-axis. So if this rectangle gets revolved about the y-axis, it's a shell, people. So I'm going to label that point xy. So, here, just do it over here. 2 pi r h dx. See how I always put the formula in with parentheses, and then I just fill in the parentheses. Okay, what's the radius of the shell? Yeah, like Lynn said, anytime you revolve it about the y-axis and it's a shell, it's going to be x. And then the height is the length of the rectangle. Top minus bottom. Minus 0. Add them up from 0 to 1/2. And what technique here? U substitution. U equals 1 minus x squared. Take it. Okay, number 6. The base of... No! Wait a minute. Time out. Isn't that the same as the quiz? I'm just looking at it now. Isn't that exactly the same as the quiz I just handed back? It's exactly the same as the quiz, people. No, that's a waste time on it then. That's a waste of time. Look, isn't this the same thing I gave on the quiz? What do you mean, maybe? The slice is an equal, no, let's waste time. Root 3 over 4 times the side squared. Now, the side of the equilateral triangle is the length of the rectangle right there, which is top minus bottom. Suzaki, this is your doing, isn't it?
Smart.
Dx. Add them up from 0 to 4. Yeah. I can't believe you put that on the board. And then number 8. And somebody squeezed it in, it looks like. Suzaki. Okay, number 8. This is the last problem of tomorrow's test. Probably going to be worth like 12 or more points. Some of you think of skipping it, therefore it's going to be 20 points. Okay, number 8. Why are you circling now? They're all on the test. Circle them all. What? Okay, the one in the book was what? What was the equation of the one in the book that I did on the board? What was this? Y equal x squared, was it? Who watched the video? Nobody watched the video, even though I told you to watch the video on there. What was it? Y equal x squared. Who has the book? I don't care what it was. It's y equal x squared. Now it's y equal x to the 4th. Ooh, what do you think tomorrow the progression is going to be? Y equal x to the 6th. Instead of 1 to the 1. And then y equal 9. Now, y equal 9 is over here. Now, if this thing gets revolved about the y-axis, notice that you only need this part right there, right, to generate this bowl, right? Now, what did we do in the video? Look, it says, look, It says use discs to find the volume of the bowl. And I already told you that in this problem, right? So you make, the rectangle's gotta be that way, so when you revolve it around, you get a disc. Which means, since you're making the rectangle horizontal, you have to solve for x in this equation. So x equals y to the 1/4 power. Okay, so what's the formula for disk? Pi times the radius squared dx. dy, dummy. And what's the radius of this disk? What's the length of the rectangle? Right minus left. Y to the 1/4 minus 0. This is y equals 0, right? And then you add up all of these from 0 to 9. Because you go from the y coordinate down there, which is 0, to the y coordinate up there, which is 9. That's why they gave you y equal 9. That's kind of like a hint that you're going to do it. Now, yes, you could have done this problem by drawing a vertical rectangle and then you're going to have shells. But then you're going to have problems in part B and C. For those of you who watched this. So, you're telling me that only one person watched the video? After I told you to watch the video. So tomorrow, if I tell you to do the test, one person will do the test.
Yeah.
I'm flabbergasted already. So this is pi. What do I do with the exponent here, Mr. Park? Some of you think, oh, the teacher not here. All right, holiday.
That's what we heard.
No, you keep up. In fact, I took down the sign over there. It says, keep up with your assignments. Watch the video. I sent you an email. Y to the 1/2 dy. Okay, look, just wasting time ranting and reading. So pi, so make the power 1 bigger, put the reciprocal in the front, from 0 to 9, factor out the constant, so we get 2 pi over 3. What is 9 to the 3 halves? That's 27 minus 0, so 9 times 18 pi. There you go. That's part A. 4 points for that. Now, the height of the water, if h is the height of the water, right? Okay, so now, what if this is the same picture I drew in the video, people. What if that's the height of the water? Like, what if the height of the water is not 9? See, 9 gives you the total volume of the bowl. What if the height
And
of
we
the
took
water
this business, and this is a free pod.
is like 4? How do you, like, what if the height of the water was 4? What would your integral be? 0 to 4, right? Because you're still adding up all of these disks, right? It's just from 0 to whatever. So if the height of the water is h, what do you think the limits of integration are going to be? 0 to h. So what's the only difference over here? You could have the same integral, but instead of 9, now it's going to be 0 to h. So what is that? What happens when I plug in h? You're going to get 2 pi over 3 times h to the 3/2 minus 0. That tells you the volume of the water in the bowl if the height of the water is h. You guys understand that? Instead of integrating from 0 to 9, you go from 0 to h. Okay, now that's part B. Now here's part C. If water is being pumped into this bowl at the rate of 5 cubic units per minute, what the heck is that?
Oh, we gotta remember that.
This is related rates. That's it. I'm very upset you guys didn't even watch the video. You know, I was sick that day, and I actually made that video while I was sick so you guys can watch it. And you guys didn't even watch it. When I go home tonight, if I don't see 500 views on there, something bad's going to happen. No, well, at least 22, because there are 22 people in this class. Can't believe it. I could have just not done anything, right? Would have been the same result. Okay, anyway, related rates. Water is being pumped into this bowl at the rate of 5 cubic units per minute, whatever, or second. What is it? Per minute. Okay, so what is that? That's dV dt. The volume is getting bigger at the rate of 5 cubic units per minute. How fast is the water level rising at the moment when the height is 4? So here, you're pouring water in. The height of the water is going up. In the beginning, it goes up fast and gets slower. So right when you hit 4 units, how fast is the height of the water going up? In other words, you have to find dH dt. Okay, we got 1 minute to do that. How would you classify this problem?
Jervis has what's that?
It's called related rates. Did I say that already?
We just said that.
Okay, so how do you do related rates? Step 1, it's a 3-step process. Write the equation, which you already did in part B. 2, take the derivative with respect to time. So dv dt equals, that's a constant, throw it on the side like an unwanted pet. What's the derivative of box to the 3 halves? 3 halves box to the 1 half times the derivative of box, which is dh dt. Now, if you do not multiply by the derivative of box dh dt, then how can you even find dh dt? That's exactly what I said in the video. That's why you got to use the chain rule. So, all you have to do to compute dh dt is plug in numbers for h and dv dt. And do we know these numbers? Yes, dv dt is 5. What is h? What does it say in the problem? 4. Solve for dh dt, and you got to put units. Anytime you do a related rates problem, you have to have units on your answer. And what are the units? So you're going to end up with dh dt equals something. What are the units going to be? Well, you just look at this. Height over time. If you have to measure the height of something, what would the units be?
Meters.
No, does it say meters in there? It says units. Units over time. How is time measured in this problem?
Minutes.
Minutes, because some of you're making up all kinds of units. All you have to do is look at this and this. That tells you what the units are going to be. Okay, this problem is on tomorrow's test. It's up, in fact, all of these are. You know, you guys are getting spoiled with this practice test. From now on, no practice test. Doesn't matter because we're not having any more. You guys better increase that view.
Wait, do you make money?
I think it's just a jolly holiday. All right, but see, probably only 2 of you came up here and said, "Oh, Mr. Park's not here," and then the word spread, and then Lum doesn't even come up here and read the note, and he doesn't even check his email.
That's easy, yeah.
You guys are weakening me.
It's gonna go 5 more classes. First thing in the morning.